In this video, we are going to go over transforming functions with multiplication. The first equation, x squared minus 8x plus 12, is going to be our original equation throughout this section. We are not going to worry about vertex, x-intercepts, or y-intercepts. Our original equation, in order to graph it, we can make a table and plug values in order to get this graph. So when I plugged in 0, it was a 12, 1, 5, 2, 0, 3, negative 3, 4, negative 4, 5, negative 3, 6, 0, 7, 5. So this is the table which allowed me to graph the original. On your notes, really quick, go through and write this original graph. So the up 5, 2, 0, down 3, down 4, 3, 0, up 5. Graph your u and make sure that you have it graphed on each example so that when you watch the notes, it's already graphed in and we can just graph over it. So pause the video and fill in this graph on every one. You don't need to do the table. Just go through and draw this graph on each graph. Alright, now that you have unpaused the video and you have a graph on each section, let's go to the first example. A vertical stretch occurs when k is bigger than 1, is greater than 1, in k times f of x. If it helps, f of x is just function notation for the letter y. And if you remember, the y-axis is up and down. It's vertical. So whenever you see this f of x, in your head you should think it's going to be a vertical, and then depending on the number, it will stretch it or it will shrink the graph. So if I take this 2 that they're asking me to make k, I'm going to plug it in. Now the equation, my original equation from the very beginning, is x squared minus 8x plus 12, which we graphed already in black. That's why I'm writing it in the same color. Now it wants me to take my original equation and times it by a 2 in the front, which would make my equation 2x squared minus 16x plus 24. And that's how you would find your equation. If it asks you to graph your new equation, you would need to make a table. So what I would do is I would plug a bunch of numbers in and see what happens, and I would keep plugging in until I make a U shape. So I plugged in a 2 and got a 0, 3, negative 6, 4, negative 8, 5, negative 6, 6 is at 0, 7 is at 10. So I plugged those all into my calculator. Now I can graph them. First one doesn't fit. 1 up 10, 2 0, 3 negative 6, then negative 8, negative 6, 0, 10. So if you notice, my x-intercepts didn't change at all. My vertex was pulled down, so I am physically doing a vertical stretch of the graph. And that's how you do a vertical stretch when you're given an equation. Find the new equation, make a table to graph it, and then identify. Next example, we have our original graph. We graphed it in already. Now we're going over what it looks like to have a vertical compression. If you don't want to write out compression, you can write that it will shrink. So whenever I have a k that is a fraction or decimal, then it's going to be a shrink. So I have k times f of x, but they want me to change that k to 1/2 f of x. I take my original equation and with that original equation, I have to put a 1/2 in front and multiply it in. 1/2 x squared, half of 8 is 4x, half of 12 is 6. And that is how I find my equation. After that, if I need to graph my new equation, I would make a table, plug numbers in, and I would see what my graph looks like. It should be a U shape, right? X squared makes a parabola. 0, 6, 1 is at 2.5, 2 is at 0, 4 is at -2, 5, 6 is at 0, 7 is at 2.5, 8 is at 6. You may graph the decimals or you may skip the decimals. You may pick 0 up 6. I can do skip 1, 2 is at 0, 4 is at -2, 6, 0, 8, 6. There's my new graph. Notice that the purple one, the vertex, so x-intercepts are the same, but the vertex was moved up. That means that I took my graph and I made it shrink. So vertically it did a shrink. Vertical, shrink. If you want to write compression, compression is also correct. So we found the equation, made a graph with a table, and identified what happened. Now we are going over horizontal compression, or you may say shrink. So I have F. This time K is being multiplied by the X. If I take that 2 and I put it in for the K, this means I need a 2x written in my equation. So my original equation is x squared minus 8x plus 12. Now, in place of every x, I need to write a 2x squared minus 8, make that x into a 2x, plus 12. 12 does not get 1 because there's no x on it. 2x squared would look like this, right? I read it twice. 2 times 2 is 4. X times x is x squared. Negative 8 times 2 is negative 16x plus 12. That is my new equation. I then need to graph it. So I'm going to make a table. We get 0, 12, 1, 0, 2, -3, 3, 0, 4, 12. 0, 12 won't fit. 1, 0, down 3, 4, wait, 3, 3, 0, and then 4, 12 won't fit. So this time, those x-intercepts used to be 1, 2, 3, 4 apart. Now my x-intercepts are 2 apart. So it just took those x's on the x-axis and it made it shrink. So this one would be a horizontal shrink or compression. So I found the new equation, graphed it by plugging in and making a table, identified what happened. I have my original graph in black. Now I'm going to take my f times k x and put a fraction in k. My original equation is x squared minus 8x plus 12. But instead of my x, I need a 1/2 x. 1/2 x squared minus 8, 1/2 x plus 12. When I have this one, 1/2 x. Right, so from your equation, you're going to create a table. When you plug in a 0, you get 12. When you plugged in 1, it's decimal, so I skipped it. 2 is 5, 3 is a decimal, 4 is 0, 5 is a decimal, 6 negative 3, 5 is decimal, 8 negative 4, 10 negative 3. Then I can get my pattern. 0, 12 won't fit. 2, 1, 2, 3, 4, 5, 4, 0, 6 negative 3, 8 negative 4, 10 negative 3, and then it would be mirrored. And because your x-intercepts were here and they stretched them out, it is a horizontal stretch. So we create an equation, graph our table that we make, and identify what happened to the graph.